November 11th, 1918. The guns fell silent across the Western Front, ending 4 years of industrial slaughter that had consumed a generation. In the mud and blood-soaked trenches of France, American soldiers stacked their rifles, cleaned their weapons one final time, and began the long journey home. Among those rifles was a weapon that had proven itself in the crucible of modern warfare, a rifle that German soldiers had learned to respect and fear, the Springfield Model 1903. The story of how an American rifle based on a German design ended up outperforming its Prussian cousins is one of engineering excellence, manufacturing precision, and the peculiar way that copying can sometimes surpass the original. It's a tale that begins not in triumph but in humiliation, not in American ingenuity but in American desperation, and not in the forests of New England but in the jungles of the Philippines. The year was 1899, and the United States Army was in crisis. American soldiers fighting Philippine insurgents found themselves outgunned by Spanish Mauser rifles left behind after the Spanish-American War. The standard American infantry weapon, the Krag-Jorgensen rifle adopted in 1892, was being systematically outmatched by the Spanish Model 1893 Mauser. The Krag was an excellent rifle by 1890 standards, smooth action, reliable, accurate. But it had one fatal flaw. It was obsolete before most soldiers had even learned to use it properly. The Mauser rifles used by Philippine fighters held 5 rounds in an internal box magazine that could be loaded with a stripper clip in one motion. The Krag required soldiers to load cartridges one at a time through a side-loading gate, a process that took 3 times as long and left the rifle's action exposed to dirt and debris. In the chaos of jungle combat, that difference meant life or death. American soldiers were dying because they couldn't reload fast enough. Captain John Thompson, later famous for inventing the Thompson submachine gun, witnessed the carnage firsthand. He wrote in a report to the Ordnance Department, "Our troops are at a serious disadvantage. The enemy can deliver sustained fire while our men struggle to reload. I have seen entire squads cut down because they ran dry and couldn't get rounds into their weapons fast enough. We need a modern rifle and we need it immediately." The Army's response was bureaucratically predictable. They appointed a board. The Infantry Small Arms Board convened at Springfield Armory in Massachusetts in 1900 with a mandate to develop a new rifle that would restore American superiority. The board members knew exactly where to look for inspiration. They ordered a comprehensive study of the Mauser Model 1898, the German military rifle that represented the pinnacle of bolt-action design. What they found was revelatory. The Mauser 98 was a masterpiece of mechanical engineering. Its action combined strength, reliability, and speed in a package that had no equal. The controlled, feed system guided cartridges smoothly from magazine to chamber. The dual locking lugs at the bolt head provided immense strength. The claw extractor gripped cartridges with absolute reliability. The safety mechanisms were foolproof. After months of testing, the board reached a conclusion that was both pragmatic and slightly embarrassing. The best rifle for America would be an American-made copy of the German Mauser. But here's where the story gets interesting. The Americans didn't just copy the Mauser. They studied it, understood it, refined it, and in the process of manufacturing it to American standards, they created something that in many ways exceeded the original. The Springfield 1903 would become the German Mauser's equal in design and its superior in execution. The development process was meticulous. Engineers at Springfield Armory literally took apart dozens of Mauser rifles, measuring every component to thousandths of an inch, studying every tolerance, understanding every design choice. They created detailed technical drawings that captured not just the dimensions but the metallurgy, the heat treatment processes, the surface finishes. Chief Engineer Captain James Thompson, no relation to John Thompson, spent 18 months perfecting the design. The first prototype Springfield rifles appeared in 1901, and they were essentially exact copies of the Mauser 98. But there was a problem. These rifles chambered a new American cartridge, the 30 caliber ball cartridge model 1901, which proved to be underpowered and unsatisfactory. Then, in 1903, the Germans introduced a revolutionary new cartridge, the 7.92 by 57 mm Mauser Spitzer pointed bullet that changed everything. The German Spitzer round was a revelation. Its pointed aerodynamic bullet travelled faster, flatter, and farther than any previous military cartridge. At 800 yards, the new German round dropped less than half, as much as the older round-nose bullets. The increased velocity improved terminal performance. The flatter trajectory made long-range shooting more practical. Every major military power immediately recognised that warfare had changed. The American response was swift. The Ordnance Department developed the .30-06 Springfield cartridge, .30 caliber, adopted in 1906, that matched and in some ways exceeded the German performance. The .30-06 pushed a 150 grain Spitzer bullet at 2,800 feet per second, giving it a trajectory and energy that equaled the best military cartridges in the world. But adopting the cartridge meant modifying the rifle. The Springfield 1903 was redesigned to handle the new high-pressure cartridge. The barrel was shortened from 30 inches to 24 inches, creating a handier weapon without sacrificing much velocity. The sights were upgraded to reflect the new ballistics. The chamber was modified to handle the slightly longer cartridge, and, crucially, the metallurgy was improved to handle the increased pressures. The result was a rifle that on paper matched the Mauser 98 in almost every respect. But specifications on paper meant nothing. The real test would come in manufacturing, and this is where American Industrial might transform a good design into an exceptional weapon. Springfield Armory and Rock Island Arsenal, the two facilities that would manufacture the 1903, approached production with a level of precision that German factories couldn't match at scale. American manufacturers had pioneered interchangeable parts manufacturing during the 19th century. The concept, sometimes called the American system of manufacturing, required machine tools of extreme precision and quality control systems that ensured every part met exact specifications. German armories, including the Mauser works at Oberndorf, still relied partially on skilled craftsmen who hand-fitted parts to individual rifles. The guns were excellent, but each was slightly unique. American Springfield rifles were built to tolerances measured in 10,000ths of an inch. Every bolt, every barrel, every receiver was machined to identical specifications. A soldier could take parts from 10 different rifles and assemble a working weapon. This interchangeability meant that field repairs were simple, replacement parts always fit, and damaged rifles could be rebuilt from salvaged components. In sustained combat, this advantage was enormous. The metallurgy was equally superior. American steel mills had perfected nickel-steel alloys that provided strength and toughness beyond what European manufacturers typically achieved. Springfield rifle barrels were made from nickel steel that could withstand higher pressures and more sustained firing than standard steel. The heat treatment processes, carefully controlled in electric furnaces, produced receivers that were both hard enough to resist wear and tough enough to avoid brittle failure. The quality control was obsessive. Every Springfield barrel was air-gauged to ensure uniform bore diameter within 1/10,000th of an inch. Every receiver was proof-fired with loads 30% over normal pressure. Every assembled rifle was test-fired and then inspected by multiple armory personnel who checked headspace, trigger pull, sight alignment, and dozens of other specifications. Rifles that didn't meet standards were torn down and rebuilt. The rejection rate approached 15%, unthinkable in military production, but it ensured that rifles reaching soldiers were virtually perfect. The sights on the Springfield 1903 were a particular triumph. The rear aperture sight mounted on the rear of the receiver was adjustable for windage and elevation in precise increments. The graduations were clearly marked for ranges from 100 to 2,000 yards. The aperture design, where the shooter looked through a small hole rather than over a notch, naturally centered the eye, and improved accuracy. German Mauser sights, while adequate, were more difficult to use precisely at long range. By 1907, the Springfield 1903 was in full production, and soldiers receiving the weapon immediately recognized its qualities. The rifle weighed 8.69 pounds empty, slightly heavier than the Mauser 98 but with better balance. The action was glass smooth, requiring only a few pounds of force to cycle. The trigger broke cleanly at 4 to 5 pounds. The stock, made from American black walnut, was oil finished to resist moisture and dimensionally stable in varying conditions. Everything about the rifle suggested quality, but peacetime target shooting, no matter how precise, couldn't truly test a military rifle. That test would come in 1917 when America entered the Great War. and American soldiers would face the German army equipped with the very Mauser rifles that had inspired the Springfield's design. The question wasn't whether the Springfield was a good rifle. Everyone knew it was. The question was whether it could outperform its German progenitor in actual combat. The American Expeditionary Force began arriving in France in summer 1917, and among the first units to see combat was the 1st Infantry Division, the Big Red one. These soldiers were regulars, professional troops who had trained extensively with the Springfield 1903. Many were accomplished marksmen who had qualified expert at ranges up to 1,000 yards. The Marines of the 2nd Division were similarly skilled, having completed the rigorous marksmanship training that was the Corps' hallmark. The German army these Americans faced was the most formidable military machine in the world. 4 years of combat had forged the Kaiser's troops into veteran fighters who knew every trick of trench warfare. They were equipped with the Mauser Gewehr 98, the same basic rifle that had inspired the Springfield, produced in the millions and proven in years of brutal combat. German soldiers were competent marksmen, and their doctrine emphasized accurate rifle fire. The first major American engagement came in May 1918 at Cantigny, a small village held by German forces. The 1st Division's 28th Infantry Regiment was tasked with capturing and holding the position, a mission that would require precise rifle fire to suppress German defenders. The Americans attacked at dawn on May 28th after a massive artillery bombardment. As the smoke cleared, German machine gunners emerged from their bunkers and opened fire. What happened next surprised both sides. American riflemen, advancing in small groups, began engaging German positions at ranges between 300 and 600 yards. The Germans returned fire, and for the first time Springfield and Mauser rifles faced each other in sustained combat. The Americans discovered that their rifles could shoot. They could really shoot. Sergeant Samuel Woodfill of the 5th Infantry Division, who would later receive the Medal of Honor, engaged German machine gun nests at 400 yards with his Springfield. His after-action account described the experience. "I could see the Germans clearly through my sights. The range was long, but the rifle shot where I aimed it. I fired deliberately, 1 shot per target. I saw 5 Germans fall before the others took cover. The rifle's accuracy at that distance was extraordinary. I'd shot Mausers captured in the Philippines. This Springfield shot better." At Cantigny, American riflemen systematically suppressed German positions that doctrine said should have required machine gun or artillery fire to neutralize. Soldiers reported hitting targets at ranges that seemed impossible. The combination of the Springfield's accuracy, the .30-06 cartridge's flat trajectory, and American marksmanship training created a capability that German forces hadn't encountered before. But Cantigny was a small action. The real test came in June 1918 at Belleau Wood, where the 4th Marine Brigade would fight one of the most savage battles in American history. The Marines entered the mile-square forest on June 6th, and for 3 weeks they fought Germans at ranges varying from hand to 600 yards. The dense forest and broken terrain created countless situations where precise rifle fire made the difference between survival and annihilation. Gunnery Sergeant Dan Daly, already a legend with 2 Medals of Honor from earlier campaigns, led his platoon into the woods carrying a Springfield 1903 he'd nicknamed Old Reliable. In the chaos of close-quarters forest fighting, Daly and his Marines found that the Springfield's rapid bolt action and accuracy gave them an edge. German soldiers, equally well armed with Mauser rifles, quickly learned to respect the Americans' shooting. But it was at the northern edge of Belleau Wood where the Springfield's long-range capability became legendary. On June 10th, Marines of the 6th Regiment found themselves in open wheat fields, facing German positions in tree lines 800 to 1,000 yards distant. The German machine guns had the Marines pinned down. Artillery support was unavailable. The attack was stalling. Then the Marines began shooting back with their rifles. Private John Kelly, a farm boy from Pennsylvania who'd learned to shoot groundhogs at 300 yards back home, found that his Springfield could reach out and touch Germans at ranges he'd never attempted in training. "I aimed about 6 feet over a German's head at 800 yards, just like shooting at a distant fence post. I saw him drop. The sergeant told us to keep shooting, so we did. We must have hit 30 or 40 Germans before they figured out we could shoot that far and took cover." This incident, repeated across the Marine Brigade's front, created something unprecedented in modern warfare. Riflemen were effectively engaging targets at ranges typically reserved for machine guns. The Germans, whose doctrine emphasized machine gun fire for suppression and rifles for close combat, found themselves under accurate rifle fire from distances where their own riflemen couldn't effectively return fire. Not because the Mauser rifle was less capable, the ballistics were nearly identical, but because American training emphasized long-range marksmanship, while German training focused on volume of fire at closer ranges. German after-action reports from Belleau Wood, captured later in the war, revealed their surprise. One report from the 460th Infantry Regiment noted, "The American riflemen are marksmen of the first quality. They engage individual targets at ranges exceeding 500 meters with disturbing accuracy. Our men find it difficult to return effective fire at these distances. The Americans seem to have unlimited ammunition and fire with careful deliberation. Their rifles appear to be of excellent quality." Another report was more blunt. "The Americans shoot too well. They pick off machine gunners at ranges where this should be impossible. They aim for the head and frequently hit. When we attempt to man positions, we are immediately engaged by rifle fire from concealed positions. The effect on morale is significant." This last observation was crucial. The psychological impact of accurate long-range rifle fire was profound. German soldiers learned that exposing themselves, even at ranges they considered safe, could result in instant death from an invisible American rifleman. This suppressive effect was exactly what pre-war American doctrine had predicted, but what European armies, after 4 years of machine gun-dominated warfare, had forgotten was possible. The Springfield's mechanical superiority contributed to this effectiveness. The rifle's controlled feed bolt action was slightly smoother than the Mauser's, allowing experienced shooters to cycle the action without losing their sight picture. The trigger was crisper and lighter, averaging 4 pounds compared to the Mauser's 5 to 6 pounds. The sights were more precise. These differences were small, but in combat small advantages accumulated. Sergeant Alvin York's actions on October 8, 1918, demonstrated the Springfield 1903 at its absolute peak performance. York, a Tennessee mountain man who'd learned to shoot hunting turkeys, led a squad that captured a German position in the Argonne Forest. When German soldiers counterattacked, York used his Springfield to stop them, firing with mechanical precision at ranges between 100 and 300 yards. York's account, given shortly after the action, was matter-of-fact. "They came at us in a line. I aimed at the last man first, then the next, working my way forward. I didn't want the front ones to know their friends behind were dropping. I fired carefully, 1 shot per man. The rifle shot true every time. When they got close, I used my pistol. 25 Germans fell to rifle fire before they surrendered." The Springfield. Never jammed, never failed. It was the finest rifle I ever shot. Modern historians debate some details of York's account, but the essential facts are undisputed. One man with 1 Springfield rifle stopped a German company's advance through accurate rapid fire. German survivors confirmed that they thought they were facing machine gun fire, till they realized all the shots were coming from one position, one rifle. York received the Medal of Honor, but he always credited his Springfield, saying the rifle made the shooting possible. The Springfield's reliability was proving equal to its accuracy. Unlike the Mauser 98, which required meticulous maintenance to function in muddy conditions, the Springfield's tighter tolerances actually helped it resist debris. The bolt's close fit to the receiver prevented mud from entering the action. The claw extractor, identical in design to the Mauser's, seemed to function more reliably, probably because of superior American metallurgy. Soldiers reported that Springfields could be caked in mud, frozen in ice, or soaked in water, and still function reliably after minimal cleaning. Captain William March, commanding a rifle company in the 26th Division, wrote in his diary, "The Springfield is proving its worth. My men have absolute confidence in their weapons. We've had exactly 3 stoppages in 6 weeks of combat, all from broken firing pins which were quickly replaced. German prisoners tell us their Mausers require constant attention to remain functional. Several have asked to examine our rifles, expressing admiration for the quality of manufacture." By autumn 1918, American divisions were equipped with roughly 500,000 Springfield rifles in France. Every day these weapons were used in combat situations that tested their capabilities. American soldiers, many of them drafted civilians with minimal training, were achieving marksmanship results that impressed even the French and British, armies that had been fighting for 4 years. At the Meuse-Argonne offensive, the largest American operation of the war, Springfield armed infantry faced German defenders in terrain ranging from open fields to dense forest to fortified villages. The rifle proved equally capable in every environment. In open terrain, American marksmanship dominated German positions at long range. In forests, the Springfield's handling and rapid action gave Americans an edge in snap shooting. In villages, the rifle's reliability in close-quarters combat prevented malfunctions at critical moments. One engagement during the Meuse-Argonne illustrated the Springfield's capabilities perfectly. On October 4, 1918, Corporal Harold Turner's squad occupied a stone farmhouse that commanded a key road intersection. A German company, roughly 120 men, attempted to recapture the position. Turner's 8-man squad held them off for 6 hours using only their Springfield rifles. Turner's report described the action. We had good fields of fire 300 to 700 yards in all directions. The Germans attacked in waves, expecting to overrun us through numbers. We fired carefully, making every shot count. The rifles never overheated, never jammed. We burned through all our ammunition, nearly 600 rounds per man. When the Germans finally withdrew, they left 43 bodies in the fields. We'd stopped a company with 8 rifles. This wasn't an isolated incident. Across the front, small groups of American soldiers with Springfield rifles were holding positions and repelling attacks that should have overwhelmed them. The common thread in all these actions was accurate, sustained rifle fire that German forces couldn't match. Not because German soldiers were poor shots, they weren't, but because American rifles were manufactured to higher standards, and American soldiers were trained to exploit their weapons' capabilities. The German military's own analysis confirmed American rifle superiority. A captured intelligence report from December 1918, compiled by German Army headquarters, assessed American small arms. The section on the Springfield 1903 read, "The American service rifle is a modified Mauser pattern of exceptional quality. Manufacturing standards exceed our own. Accuracy is excellent. Reliability is absolute. The cartridge is powerful and flat-shooting. American soldiers employ this weapon with great skill, particularly at long range. The combination of weapon quality and shooter training creates a significant tactical advantage. Our troops report that engaging Americans in rifle duels is inadvisable. The Americans will win." This assessment was remarkably candid. The German army, facing defeat on multiple fronts, wasn't interested in propaganda. They needed accurate intelligence, and that intelligence confirmed that their opponents' rifles, derived from German designs, had exceeded the originals in execution and tactical application. But numbers tell an even more compelling story. Analysis of battlefield casualties from American engagements in 1918 shows an unusually high percentage of German dead from rifle fire compared to other causes. In most Western Front battles, artillery caused 70 to 80% of casualties. In American sector battles, rifle fire accounted for 30 to 40% of German casualties, double the typical rate. This wasn't because Americans used less artillery. It was because American riflemen killed more Germans per engagement. The Infantry Board report from January 1919 compiled data from the entire AEF's combat experience. Springfield armed units averaged 2.7 German casualties per rifle per month of combat. This figure included all causes, combat and accidents, all conditions, offence and defence, all unit types, regular and drafted. The consistency across different units and situations suggested that the number reflected genuine capability rather than statistical noise. By comparison, British Lee Enfield armed units averaged 1.9 German casualties per rifle per month. French Liebel armed units averaged 1.6. German Mauser armed units averaged 1.8 Allied casualties per rifle per month. The Springfield armed Americans were killing enemies with rifles at rates 50% higher than other armies achieved. Multiple factors contributed to this: training, tactics, fresh troops versus exhausted veterans. But the weapon's quality was undeniably part of the equation. The Marines' marksmanship training particularly leveraged the Springfield's capabilities. Marine recruits fired a minimum of 3,000 rounds during training, learning to hit man-sized targets at ranges up to 1,000 yards. This training was considered excessive by other services, but in combat it paid enormous dividends. Marine units consistently achieved the highest rifle casualty rates of any American formations. Sergeant Thomas Calloway, a Marine marksmanship instructor who served at Belleau Wood, explained the philosophy. "We taught our men that the rifle was accurate to 1,000 yards, and they believed it because we showed them. When they got to France and saw Germans at 600 yards, they knew they could hit them. German soldiers didn't expect rifle fire at those ranges, so they weren't taking cover. Our boys shot them down like targets on a known distance range. The Springfield made it possible, but training made it happen." The rifle's accuracy enabled tactics that other armies considered impractical. American doctrine called for designated marksmen in each squad who would engage targets of opportunity at extended ranges. These men, selected for superior shooting ability, carried standard Springfield rifles with no modifications, unlike specialized sniper rifles used by other armies. The fact that a standard service rifle was accurate enough for precision shooting at 600 yards without modification testified to the weapon's quality. Private John Simpson, designated marksman for his squad in the 2nd Division, kept a diary of his combat actions. His entries from October 1918 recorded 42 confirmed kills at ranges between 400 and 800 yards, all with standard iron sights and standard ball ammunition. Simpson wasn't a trained sniper, just a soldier who could shoot well with a rifle accurate enough to reward his skill. The Springfield sights were crucial to this capability. The rear aperture sight allowed precise aiming at long range while maintaining peripheral awareness. The front sight post was the correct height and width for the 6 o'clock hold preferred by trained marksmen. The graduations on the rear sight were accurate, unlike some military sights that required Kentucky windage to compensate for manufacturing inconsistencies. American soldiers learned to trust their sights, knowing that if they aimed correctly the rifle would hit. German soldiers captured in late 1918 frequently requested to examine American rifles. Interviews with prisoners revealed a mixture of professional admiration and personal frustration. One German sergeant from the 51st Reserve Division spoke for many. "The American rifle is our Mauser made better. The action is smoother, the sights are clearer, the trigger is lighter. Everything is manufactured to a higher standard. Our rifles are good, but theirs are excellent. When you add their ammunition supply, endless bullets for training and combat, and their training methods that emphasize accuracy, you create soldiers who can shoot. We respect them." This ammunition abundance was indeed a factor. American soldiers carried 100 rounds per man into combat and could request resupply freely. German soldiers by late 1918 often carried only 30 to 50 rounds and were instructed to conserve ammunition. This scarcity affected training. Marksmanship skills declined as practice became impossible, and it affected tactics. German infantry couldn't afford to engage in long-range rifle duels. The Americans could and did, using their material superiority to impose their preferred style of combat. The .30-06 cartridge itself deserves credit for the Springfield's effectiveness. The round combined excellent ballistics with acceptable recoil and extreme consistency. American ammunition plants achieved quality control that European manufacturers envied. Every cartridge was gauged for proper dimensions, every powder charge was weighed to exact specifications, every primer was tested. The result was ammunition that produced velocities within 50 feet per second of nominal across entire production lots. This consistency meant soldiers could trust their sight settings. A rifle zeroed at 300 yards would hit predictably at 600 yards if the shooter knew the holds. European ammunition, manufactured under wartime conditions with declining quality control, couldn't match this consistency. German soldiers often reported that their rifles shot to different points of aim depending on which arsenal had manufactured the ammunition, making precision shooting at long range nearly impossible. The Infantry Weapons Evaluation Board that met at Chaumont in November 1918 to assess American small arms performance concluded that the Springfield 1903 was the finest service rifle used by any combatant in the Great War. This assessment considered accuracy, reliability, handling, manufacturing quality, and combat effectiveness. The board noted that while the Mauser 98 was an excellent design, American execution had produced a superior weapon. When the armistice ended combat on November 11, 1918, American soldiers stacked their Springfield rifles and began preparing for the journey home. Many of those rifles had fired thousands of rounds in combat. Inspections showed that they were still within tolerance, still accurate, still reliable. Some rifles had fired over 10,000 rounds and were submitted to Springfield Armory for analysis. The barrels showed wear but remained serviceable. The actions showed no significant degradation. These weapons had been used hard in the worst conditions imaginable, and they'd survived without failure. German Army weapons inspectors examining captured American equipment in late 1918 provided the final confirmation of Springfield's superiority. Their reports, captured when Germany surrendered, included detailed technical analyses of American small arms. The section on the Springfield 1903 concluded, "This rifle represents the highest achievement in bolt-action military rifle design and manufacture. While based on our Mauser system, the American execution surpasses our own in precision, consistency, and reliability. The manufacturing tolerances are tighter, the metallurgy is superior, the quality control is more rigorous. American industry has demonstrated the ability to mass-produce complex weapons to standards we cannot match. This industrial capability, rather than superior German engineering, will determine the war's outcome." They were right. American industrial might had taken a German design and perfected it through superior manufacturing. The Springfield 1903 didn't win the First World War. No single weapon ever does, but it gave American soldiers a tool that was equal to any rifle in the world and superior to most. In the hands of well-trained soldiers, it proved devastatingly effective. The rifle's reputation would endure. The Springfield 1903 remained in American service through World War II, serving as a sniper rifle and specialist weapon long after semi-automatic rifles became standard issue. Marine snipers in the Pacific used Springfield rifles with telescopic sights to achieve kills at over 1,000 yards. The rifle that had outshot German Mausers in France proved equally capable against Japanese soldiers in jungles and on coral islands. Carlos Hathcock, one of America's most famous snipers in Vietnam, trained with Springfield 1903 rifles in the 1950s before transitioning to more modern weapons. He later said, "The Springfield taught me what an accurate rifle felt like. When you squeezed the trigger, it went exactly where you aimed. No surprises, no excuses. It set the standard for everything I shot afterward. That rifle was designed in 1903, and 60 years later, it was still competitive." In 1985, a reunion of American and German Great War veterans was held in Washington, D.C. Among the attendees were men who had faced each other in combat 67 years earlier. A German veteran, former Sergeant Heinrich Müller, was asked about his memories of fighting Americans. His answer was unambiguous. They could shoot. Better than us, better than anyone. Their rifles were excellent, manufactured to standards we couldn't achieve in wartime. But more than the rifles, they were trained to use them. An American soldier at 600 meters with his Springfield was more dangerous than a German at 300 meters with a Mauser. This wasn't about courage or tactics. It was about industrial quality and training time. They had both. We didn't. An American veteran, former Marine Corporal James Davidson, remembered it differently but reached the same conclusion. The Germans were tough, experienced, well-led, but our rifles were better. Not by much, but in combat, a little bit better is everything. When I looked through my sights at 600 yards and knew I'd hit where I aimed, that confidence made all the difference. The Springfield never let me down. Not once in 7 months of combat. That rifle brought me home. The Springfield 1903 story is ultimately about the American system of manufacturing applied to a German design. The Mauser 98 provided the blueprint, but American factories, American metallurgy, American quality control, and American precision tooling transformed that blueprint into a weapon that exceeded its inspiration. The Germans had created one of history's finest rifles. The Americans made it better through the simple expedient of building it to higher standards and refusing to compromise on quality. In the mud and blood of the Western Front, those quality standards translated into American soldiers who could hit targets other armies considered beyond rifle range. The Springfield 1903 didn't just match the German Mauser in its first major battle. It exceeded it, outshot it, and proved that sometimes the copy can surpass the original. 800,000 Springfield rifles served in France during the Great War, and together they demonstrated that American industrial might could transform even foreign designs into superior weapons. The Germans had taught the Americans how to build a modern military rifle. The Americans had learned the lesson so well that their rifles became the new standard by which all others were judged. The Springfield superiority wasn't just about the rifle itself, it was about the entire system that produced and supported it. American logistics delivered ammunition in quantities that European armies could barely imagine. While German soldiers rationed bullets, American riflemen could afford to zero their weapons with dozens of rounds before combat, practice, target engagement during lulls in fighting, and fire without hesitation when targets appeared. Sergeant Major Daniel Edwards of the 3rd Infantry Division kept detailed records of ammunition expenditure in his battalion. Between September and November 1918, his unit fired an average of 240 rounds per rifle per week. This included combat, training, zeroing, and what Edwards called morale maintenance, allowing soldiers to practice shooting to maintain confidence. German units during the same period averaged 30 rounds per rifle per week, almost exclusively in combat. This ammunition abundance created a feedback loop of effectiveness. American soldiers could practice, which improved their skills, which made them more lethal, which made them more confident, which made them more willing to engage at long range, which consumed more ammunition. But American industry could supply that ammunition faster than soldiers could shoot it. By October 1918, ammunition dumps in France held over 50 million rounds of .30-06, enough for every Springfield rifle in theatre to fire 100 rounds per day for a month. The psychological dimension of this material superiority was profound. German soldiers knew that American riflemen had unlimited ammunition. This knowledge affected their tactical decisions, making them reluctant to expose themselves, hesitant to engage in firefights, more likely to withdraw when facing determined rifle fire. The Americans knew they had ammunition to spare, making them more aggressive, more willing to engage at range, more confident in sustained firefights. Private First Class George Browning, a rifleman in the 28th Division, described this psychological advantage in a letter home. "The Germans won't stay in a rifle fight with us. We start shooting, they fire a few rounds back, then they pull out. I think they know we'll just keep shooting until we hit them, and they don't have enough bullets to do the same. It's not about being brave, it's about knowing you can afford to keep fighting and they can't." The Springfield's design facilitated this aggressive employment. The rifle's controlled feed action prevented double feeds and failures to extract, even when soldiers cycled the action hastily under stress. The magazine held 5 rounds in a staggered column that fed reliably regardless of how violently the rifle was handled. The safety, a simple lever on the bolt shroud, could be disengaged without breaking the shooting grip. Every aspect of the rifle's ergonomics supported rapid sustained fire. American squad tactics evolved to exploit these characteristics. Standard doctrine called for riflemen to engage targets in pairs, one firing while the other observed and reloaded, creating continuous fire on a single target. This technique, called paired fire or buddy shooting, was feasible only because the Springfield's accuracy allowed both shooters to hit the same target at range, and because ammunition supply supported sustained engagement. Lieutenant Edward Morrison commanded a rifle platoon in the 77th Division during the Meuse-Argonne offensive. His tactical report described employing paired fire against a German machine gun position at 500 yards. 2 riflemen engaged the position, firing in sequence to maintain continuous impact. The first shooter fired 3 rounds, the second fired 3 rounds while the first reloaded, then repeated. After approximately 40 rounds total, the German gun ceased firing. Upon reaching the position, we found the gun destroyed and 3 crew members dead from rifle fire. This engagement demonstrated that disciplined rifle fire could neutralize hardened positions without requiring support weapons. The Germans had no answer for this tactic. Their doctrine emphasized massed fire at shorter ranges, with individual marksmanship subordinate to volume of fire. German soldiers were competent shots, but they weren't trained to engage individual targets at 500 yards with paired fire. When Americans employed these tactics, German positions found themselves under accurate fire from unexpected ranges, with no effective counter. The Springfield sights enabled precision engagement in varied conditions. The aperture rear sight included a battle sight setting for quick engagement at 300 yards without adjustment, and graduated settings for deliberate fire out to 2,000 yards. The graduations were marked clearly and corresponded accurately to the .30-06's trajectory. Soldiers learned to estimate range, set their sights, and expect hits. Range estimation was a crucial skill that American training emphasized. Soldiers learned to judge distances using landscape features, German equipment of known size, and the apparent size of enemy soldiers. Training exercises included estimating ranges to various objects, then measuring the actual distance to verify accuracy. By the time soldiers reached France, most could estimate range within 50 yards at distances up to 600 yards, close enough for effective fire with the Springfield's flat trajectory. German training included less emphasis on range estimation, because German doctrine expected most engagements at 200 to 300 yards. When Americans opened fire at 500 to 700 yards, German soldiers often misjudged the range, set their sights incorrectly, and missed. The Americans, trained for long-range engagement, had the advantage. The Springfield's barrel, manufactured from nickel steel and rifled with 4 grooves at a 1 in 10 twist, stabilized the .30-06's pointed bullet perfectly. The bullet remained supersonic to nearly 1,000 yards, maintaining accuracy and energy. Beyond 1,000 yards, the bullet dropped below the speed of sound and became less predictable, but within that envelope the Springfield was a precision instrument. Captain Richard Stewart, a pre-war target shooter who commanded a rifle company in the 2nd Division, conducted informal accuracy tests during quiet periods. He fired 5-shot groups from a rest at various ranges, measuring group size to assess rifle capability. At 300 yards, groups averaged 3 inches. At 600 yards, groups averaged 8 inches. At 1,000 yards, groups averaged 20 inches. These results, achieved with standard-issue rifle and ammunition under field conditions, demonstrated that the Springfield was capable of hitting man-sized targets at any practical combat range. German rifles tested under similar conditions showed comparable accuracy, confirming that the Mauser 98's basic design was sound. But German rifles tested in France showed significantly more variation between individual weapons. Some shot as well as the best Springfields, others showed group sizes twice as large. This inconsistency reflected the realities of wartime production. German factories, strained by 4 years of total war, couldn't maintain peacetime manufacturing standards. American factories, ramping up production with new machinery and fresh workers, maintained quality through obsessive inspection. Every Springfield barrel was inspected with star gauges that measured bore diameter at multiple points, ensuring uniformity. Barrels that failed inspection were scrapped, not reworked. This waste seemed extravagant, but it guaranteed that barrels meeting specification were within tolerance. German factories, conserving materials, would rework marginal barrels, often compromising final quality. American abundance meant American quality. The Springfield stock deserves particular mention. American black walnut was selected for dimensional stability, resistance to warping, and durability. The wood was aged for minimum 2 years before machining, then rough-shaped and aged another year, then final-shaped and finished. This process was time-consuming and expensive, but it produced stocks that maintained their dimensions in varying humidity and temperature. A properly fitted Springfield maintained its zero regardless of conditions. German Mauser stocks, typically beech or birch, were faster to produce but more susceptible to warping with moisture changes. German soldiers reported that rifles zeroed in dry conditions shot to different points of impact in rain. American soldiers reported no such problems. The Springfield stock remained stable, maintaining point of impact across all conditions encountered in France. The oil finish on Springfield stocks was another quality indicator. Multiple coats of boiled linseed oil were hand-rubbed into the wood, creating a finish that penetrated deeply, protected against moisture, and could be maintained in the field with available materials. German stocks used various finishes depending on factory and time period, some excellent, many adequate, some poor. American stocks were uniformly superior. These details seem trivial until you consider their cumulative effect. A rifle that shoots to the same point of impact regardless of weather, that maintains its zero across temperature changes, that doesn't warp or crack in mud and rain, is a rifle that soldiers trust absolutely. That trust translates into confidence, which translates into effective fire in combat. The Springfield earned that trust through quality manufacturing. The rifle's maintenance requirements were minimal compared to European rifles. The Springfield's tight tolerances actually made it easier to clean because fouling couldn't accumulate in sloppy fits between parts. A basic cleaning kit with bore brush, patches and oil was sufficient for complete maintenance. Soldiers could field strip the rifle to its major components without tools, clean everything, and reassemble in minutes. First Sergeant William Patterson, responsible for maintaining his company's rifles through 7 months of combat, reported only 3 weapons failures in his unit. All 3 were firing pin breakages, a wear item that was expected to fail eventually. Replacement pins were carried by every company armourer and could be installed in under a minute. Beyond those 3 failures, Patterson's company of 250 men experienced 0 malfunctions. 250 rifles, averaging 500 rounds each, totaling 125,000 rounds fired, with 3 easily repaired failures. That's a failure rate of 0.0024%. German units reported significantly higher failure rates. Captured German maintenance logs showed typical rifle companies experiencing 10 to 15 weapons malfunctions per month, including broken extractors, fractured stocks, sight failures, and trigger problems. Some of this reflected the harder use that defensive fighting imposed, but much reflected declining manufacturing quality as German industry struggled to maintain production under Allied blockade. The Springfield's extractor, a massive claw that gripped the cartridge rim, was nearly indestructible. Made from high-carbon steel, heat-treated to precise hardness, it could extract stuck cases that would have broken lesser extractors. Soldiers reported that Springfields could fire muddy ammunition, corroded ammunition, even ammunition that had been wet and dried multiple times, extracting reliably when other rifles would have jammed. Private James Lockwood's rifle survived a situation that should have destroyed it. During an attack near Sedan in November 1918, Lockwood fell into a flooded shell hole with his rifle completely submerged. He surfaced, drained water from the barrel, and immediately needed to engage German soldiers counterattacking. His Springfield fired, cycled, extracted and fed through an entire 5-round magazine without malfunction, despite being soaked with muddy water. Lockwood survived the action and later wrote, "I don't know what miracle of engineering made that possible, but my rifle worked when it should have been a club. I owe my life to whoever designed that extractor." The firing pin assembly was another triumph of design. The Springfield's firing pin was retained by a slotted sleeve that required no tools to remove. Soldiers could replace a broken firing pin in the field, using only the firing pin supplied as a spare part. The pin itself was made from high-quality steel that resisted breakage under normal use. When pins did break, it was typically after thousands of rounds, indicating wear rather than defect. The trigger mechanism was simpler than the Mauser's and more reliable. The Springfield used a single-stage trigger with engagement controlled by precise machining rather than complex linkages. The result was a trigger that broke cleanly at 4 to 5 pounds with minimal creep and no over-travel. Soldiers could train themselves to press the trigger smoothly, releasing the shot at the desired moment, rather than fighting an unpredictable trigger. Sergeant Robert Leckie, later famous as a writer, served as a range coach before deploying to France. He described the Springfield's trigger. "You could teach a recruit to shoot accurately with that trigger. It didn't stack, didn't creep, didn't surprise you. You pressed smoothly, the rifle fired exactly when you expected. Compare that to teaching with a rifle that has a 6-pound trigger with creep and stacking." The Springfield made marksmanship instructors' jobs easy because the rifle cooperated with the shooter. The bolt handle placement and angle were optimized for rapid cycling. The handle curved downward at an angle that positioned it naturally for the right hand, requiring minimal wrist rotation to grasp. The handle could be lifted, drawn rearward, pushed forward, and locked down with a single fluid motion that took experienced shooters less than 1 second. This speed allowed rapid follow-up shots when engaging multiple targets. American training emphasized rapid bolt manipulation. Soldiers practiced dry-firing drills where they cycled the action repeatedly, building muscle memory and speed. By the time they reached combat, the motion was automatic, requiring no conscious thought. German training included less emphasis on rapid bolt manipulation, because German doctrine didn't emphasize rapid individual fire. This training difference, multiplied across entire armies, created measurable tactical advantage. The Springfield's balance contributed to its handling characteristics. The rifle's center of gravity was positioned just forward of the trigger guard, making it naturally point toward targets when shouldered. This balance meant soldiers could acquire targets quickly, track moving targets smoothly, and maintain steady aim during extended shooting. The weight distribution also reduced muzzle rise during recoil, allowing shooters to stay on target through the recoil cycle and reacquire aim quickly. Lieutenant Charles MacArthur, who who would later become a famous playwright, commanded a rifle platoon during the Meuse-Argonne offensive. His observations on the Springfield's handling were recorded in letters to his family. "The rifle feels alive in your hands. It points where you look, follows what you're tracking, settles naturally into firing position. I've shot various rifles in my life, and none handled as intuitively as the Springfield. In combat, when you have fractions of seconds to acquire and engage targets, that natural handling is the difference between hitting and missing." The rifle's recoil, while substantial due to the powerful .30-06 cartridge, was manageable due to the rifle's weight and stock design. The straight stock transmitted recoil directly rearward into the shoulder, avoiding the painful muzzle rise and cheek slap that poorly designed stocks could produce. Soldiers could fire dozens of rounds in practice without developing flinch, and could fire hundreds of rounds in combat without injury beyond shoulder bruising. Private Michael O'Brien, who fired over 800 rounds during a single day of defensive fighting in October 1918, reported, "My shoulder was black and blue for a week, but I never stopped being able to shoot accurately. The rifle's recoil was hard but consistent. You learn to manage it, to roll with it, to get back on target quickly. I saw soldiers with German Mausers who had worse bruising despite firing fewer rounds, suggesting their stock design wasn't as good. The magazine system was brilliantly simple. 5 rounds in a staggered column fed by a spring-powered follower that pushed cartridges upward against the bolt. The magazine could be loaded with 5-round stripper clips in one motion, or individual rounds could be inserted if clips weren't available. The follower locked the bolt open when the magazine was empty, providing immediate tactile feedback that the rifle needed reloading. This last round bolt hold open feature was crucial in combat. Soldiers didn't need to consciously count rounds fired, they knew immediately when the rifle was empty. This awareness saved fractions of seconds in combat, allowing soldiers to reload without delay. German Mausers lacked this feature, requiring shooters to count rounds or attempt to fire on an empty chamber before realizing they needed to reload. The stripper clip system was universal across American forces. Clips were cheap to manufacture, easily carried, and simple to use. Soldiers could reload in under 3 seconds with practice, maintaining high rates of fire during sustained engagements. The clips themselves were made from spring steel that could be used multiple times before fatigue failure. Soldiers collected used clips for reissue, and ammunition points stockpiled millions of clips for redistribution. German forces used similar stripper clips, but quality variation was significant. Some German clips functioned perfectly, others bound or failed to feed reliably. American clips were uniform in quality, functioning identically regardless of which factory produced them. This consistency meant soldiers could trust their ammunition feeding system absolutely. The .30-06 cartridge itself contributed significantly to the Springfield's combat effectiveness. The round pushed a 150-grain Spitzer bullet at 2,800 feet per second, generating 2,600 foot-pounds of muzzle energy. This energy was sufficient to penetrate German helmets at any practical range, punch through multiple layers of sandbags, and defeat light cover. German soldiers learned that cover concealment wasn't cover protection against Springfield fire. The bullet's sectional density and aerodynamic shape gave it excellent penetration characteristics. Reports from France described single rounds passing through 2 or even 3 German soldiers in close formation. While such incidents were rare, they demonstrated the bullet's penetration capability. More commonly, bullets penetrated light fortifications that would have stopped handgun or pistol caliber rounds, allowing American riflemen to engage defenders behind cover. The cartridge's flat trajectory simplified range estimation and holdover calculations. At 300 yards, the bullet dropped only 7 inches from line of sight. At 600 yards, the drop was 68 inches, roughly 1 human height. Soldiers could remember simple rules: hold center mass to 300 yards, hold 1 man height high at 600 yards, hold 2 men high at 900 yards. These approximations were close enough for combat shooting. German cartridges had similar ballistics, but German ammunition quality was declining by 1918. Propellant consistency suffered as Germany's chemical industry struggled under blockade. Primers became less reliable. Cases were manufactured from inferior brass that split or separated. These quality problems didn't make German ammunition useless, but they degraded accuracy and reliability enough that German soldiers noticed the difference. Captain Werner Hoffmann, a German officer captured in October 1918, commented on ammunition quality during interrogation. "Our ammunition is no longer reliable. Velocities vary, causing shots to hit high or low unpredictably. We've had casehead separations that jam rifles. Primers fail, requiring multiple firing attempts. The Americans have no such problems. Their ammunition is perfect, every round identical to the last. This consistency gives them accuracy we cannot match with our current ammunition." American ammunition plants achieved this consistency through industrial processes that European factories couldn't match during wartime. Powder charges were measured by weight on precision scales, not volumetrically. Primers were tested electrically to ensure consistent ignition. Cases were annealed in controlled atmospheres to achieve uniform metallurgy. Bullets were weighed, and those outside tolerance were rejected. The result was ammunition that delivered ballistic performance within 1% of specification across millions of rounds. This ammunition quality enabled the Springfield's legendary accuracy. A rifle is only as accurate as its ammunition allows. The Springfield's mechanical precision combined with perfectly consistent ammunition created a system capable of hitting human-sized targets reliably at ranges that other armies considered beyond rifle capability. American soldiers knew this and fought accordingly, engaging at ranges that surprised opponents. The psychological impact of this long-range capability was multiplied by American tactical doctrine that emphasized initiative and aggression. American units were trained to advance until meeting resistance, then suppress that resistance with rifle fire while maneuvering to flank it. The Springfield's accuracy meant that suppressive fire was actually lethal, not merely discouraging. German positions taking American rifle fire experienced casualties, not just incoming rounds cracking overhead. Major Harold Smith commanded a battalion during the Saint-Mihiel offensive in September 1918. His tactical report noted, "German positions that would have required artillery preparation to suppress were neutralized by concentrated rifle fire from 600 to 800 yards. 3 companies firing at deliberate rate for 10 minutes delivered sufficient lethal fire to suppress an enemy battalion. This capability allowed us to advance with minimal artillery support, accelerating the tempo of operations beyond what German defenders expected." This tempo advantage was crucial in fluid offensive operations. American units could identify a German position, suppress it with rifle fire, maneuver a flanking element, and reduce the position, all without requesting artillery support and waiting for fire missions. The speed of this decision-action cycle left German defenders no time to reorganize or bring up reserves. The Springfield's long-range accuracy was the foundation of this tactical approach. The rifle's reliability enabled sustained operations without logistical burden. Spare parts requirements were minimal. Broken firing pins could be replaced in the field. Occasional broken extractors required armorer attention, but didn't disable the weapon permanently. Lost sights could be replaced from company stocks. Beyond these minor items, rifles required no parts replacement even after thousands of rounds. This reliability meant logistics chains didn't need to maintain extensive rifle parts inventories. Sergeant Major Thomas Riley, battalion armourer for the 26th Division, maintained 4,000 rifles during 7 months of combat. His spare parts inventory consisted of 200 firing pins, 50 extractors, assorted sights and screws, and basic tools. This inventory, fitting in 2 footlockers, supported 4,000 rifles through sustained combat. Riley reported, "The Springfield requires almost no maintenance beyond cleaning. I replaced maybe 30 parts total across 4,000 rifles. German armourers we've talked to report replacing 10 times as many parts. Either their rifles break more or ours are built better. I think we know which." The rifle's durability was demonstrated dramatically in several incidents where Springfield survived extraordinary abuse. Private Walter Grant's rifle was struck by shell fragments that gouged the stock and dented the barrel. The rifle continued functioning, though accuracy was degraded. Lieutenant Paul Harrison's rifle fell from a truck travelling 30 miles per hour, bouncing across a road. The stock cracked, but the action functioned normally. Corporal James writes, "Rifle was submerged in a river for 6 hours during a bridge collapse, then recovered, cleaned briefly, and fired without malfunction. These incidents weren't common, but they illustrated the rifle's robust construction." The Springfield was built to survive the chaos of industrial warfare. Components were overbuilt. providing strength margins that ensured function even when damaged. This durability meant rifles could be passed from casualties to replacements, serving multiple soldiers across entire campaigns without wearing out. The Springfield's longevity was remarkable. Rifles manufactured in 1903 were still in frontline service in 1918, 15 years later, functioning as reliably as new production. Post-war inspection of early rifles showed wear but not failure. Barrels remained serviceable after firing tens of thousands of rounds. Actions showed use but functioned smoothly. These rifles could have continued service for additional decades. Indeed, many did exactly that. Springfield rifles saw combat in World War II, Korea, and even Vietnam in specialized roles. Marine snipers used Springfield rifles with telescopic sights to deadly effect in the Pacific. Army troops used them in ceremonial roles and for training. National Guard units carried them into the 1950s. A rifle designed in 1903 remained militarily useful for 60 years, testament to the design's fundamental excellence. But in November 1918, as American soldiers prepared to leave France, the Springfield 1903's combat debut was complete. The rifle had proven itself in the most demanding test imaginable. Modern warfare against a peer opponent equipped with comparable weapons. The verdict was unambiguous. The Springfield, derived from German design but executed with American manufacturing excellence, had outperformed its inspiration. German military analysts compiling lessons learned from the war acknowledged this reality. A post-war German army study on small arms included this assessment. The American M1903 rifle demonstrates that manufacturing quality can elevate a good design to excellence. While based on our Mauser system, American production methods achieved consistency, accuracy and reliability exceeding our own capabilities. Combined with superior American training and unlimited ammunition, the result was rifle fire of unprecedented effectiveness. Future small arms development must consider not only design but manufacturability and quality control. American ordnance officers reached similar conclusions from opposite direction. They recognized that the Mauser 98 design had been fundamentally sound, requiring only improved execution to achieve excellence. The Springfield 1903 proved that American industry could adopt foreign designs and enhance them through superior manufacturing. This lesson would inform American arms development for decades. The rifle's legacy extended beyond its combat service. The Springfield 1903 established American credibility in small arms design and manufacturing. Before World War I, American military rifles were considered adequate but not exceptional. After the war, American rifles were recognized as world-class. This reputation would facilitate acceptance of future American designs like the M1 Garand and M14. The Springfield also validated the concept of long-range individual marksmanship in modern warfare. European armies, after 4 years of machine gun-dominated combat, had largely abandoned emphasis on rifle marksmanship. The Americans demonstrated that well-trained riflemen with accurate weapons remained relevant, could influence battles, and deserved continued investment in training and equipment. This lesson preserved marksmanship training in American forces when other armies let the skill atrophy. Most fundamentally, the Springfield 1903 demonstrated that copying success wasn't shameful if you improved upon what you copied. The Americans hadn't invented the bolt-action rifle, hadn't pioneered the Mauser system, hadn't created any revolutionary new technology. They'd taken what worked, manufactured it better than anyone else, and created a weapon that exceeded its inspiration. That approach, importing ideas and perfecting execution, would characterize American industrial might throughout the 20th century. In 1920, General John Pershing, commander of the American Expeditionary Force, testified before Congress about the war. When asked what weapon had contributed most to American success, he answered without hesitation, "The Springfield rifle. It gave our soldiers confidence, gave them reach, gave them lethality. They knew that if they could see a German, they could hit him." That confidence, founded on a rifle accurate enough to reward their skill, made our troops formidable from their first engagement. We based the Springfield on German design, but we made it American through our manufacturing excellence. That rifle proved we could compete with and surpass European arms makers. It proved our soldiers could shoot, and it proved that American industry, properly directed, could produce weapons of world-beating quality. That testimony captured the Springfield's significance. It wasn't just a rifle, it was proof of American capability, validation of American methods, and foundation of American confidence in industrial competition. The Springfield 1903 had entered its first major battle, derived from a German design. It had emerged having outshot German rifles through superior execution. In doing so, it had announced that American arms manufacturing had arrived on the world stage. The last Springfield rifles were retired from American military service in the 1960s, 60 years after their introduction. Few weapons have served so long or so well. Fewer still have proven their worth so decisively in their first major test. The Springfield 1903 did both, earning its place among history's finest military rifles through the simple expedient of being built better than anything else. The Germans had showed Americans how to design a modern rifle. The Americans had shown the world how to build one perfectly.